So you have to do the EC. Now, know that here, the last rule that I'm going to tell you here, we have mentioned two rules. The art of equating a compound to be zero, the art of equating a radical to be what is carrying as the charge. Then the third rule is that you have to make use of their atomic number in order to solve this by finding their outer valency. When I say outer valency, atomic numbers for what? For sodium is 11. Atomic number, meaning hydrogen, helium, lithium. 11, sodium formula number 11, we call that atomic number. Then you have to spin them by finding the electronic configuration, which is 2, what? 8, 1. 2 plus 8 is what? 10 plus 1, 11. So what I mean by this is that the EC is electronic configuration is 2, 8, 1, which is, this is what I'm actually saying. This is 2, which is K. Have you recall about that? KLMNO share. This is 8 now. 1, 2, 3. This is 6 now. This is 8. Know that K must be 2 duplex. That this one, octets must be what? Must be 8. Must not be more than 8. 8. Then the other one here, which is 1. 1. Am I communicating? Now this is 1. Know that this one now is looking for how many? This is 2. This is 2. We spin this to be 2. This is 8. We have spin this to be 8. That is the maximum limit. Now this should be 8 as well. Everything is 8. But note that can we actually remain how many for this to be balanced? Remain 7. Isn't it? And anything that is looking for a highest electron, looking for 7, looking for 6, you classify them to what? To metal. That is why sodium happens to be a metal. Or you can use 1, 2, 3 is also applicable. But note that what I'm actually saying, please listen, what I'm actually saying, 1, 2, 3, 4, 5, 6, 7, 8. You can make use of 1, 2, 3. Know that 1, 2, 3 is what we call metal. You can use that. 4 is what we know as what? Is what we know as non-metal. Is what we know as metalloid. Don't mind me, metalloid. 5, 6, 7 is what we call non-metal. Non-metal. Y8 is what we call noble gas. Please try and note that. The use of using 1, 2, 3 in order to know metal, metalloid, non-metal, noble gas. When we say metal, meaning let's check this. Is it metal? And know that the charge that will always be on metal, it is what? Plus. Plus. Metal has plus. Non-metal always have minus. It's looking for something. This is losing something. When plus, meaning it's losing something. Y minus, meaning it's attracting something. Now note that this 4 will be metalloid. Y8 will be noble gas. Why? It's as a result of, if you want to apply 1, 2, 3 in order to know, to classify an element into metal, non-metal, metalloid or noble gas, always be checking the outer valency. When I say outer valency, the last share, check the electron that is there. How many electrons that is there is what we call valency. This is the first share, 1. This is the second share, 2. This is the last share. Now let's check the electron. It is 1. Are we together? And you know, when we always check, not the inner one, what the first one, always be checking the outer valency. It will tell you if a compound if an element, happens to be a metal, metalloid, non-metal, or noble gas. Now, please, I know you will know the answer. How sodium now that we split as a result of the atomic number we use. What is it metal now based on this, or non-metal, or metalloid, or what? Noble gas. It is metal. Why? What is the outer share that is there? How many electrons? 1. And we said anything that fall on 1, or we still have 2 at the outer share, that last share that we draw, or 3 at the last share that we draw, is what we call what? Is what we call metal. Are we? This one is an exceptional case. Hydrogen plus is also plus, because it's having 1 here, but it's an exceptional case. The plus that is having, it's not that, it's maybe signifying that it is metal. It is not metal, but they do use plus as a result of what is carrying here, because you haven't completed this. talk less of finding the outer shell. Are we together? So note, that is the exceptional case. Hydrogen is plus, but it's non-metal. Now what I'm saying is that, now let's classify this sodium. I told you that already we have known how many outer shell, last shell is what? Is having one. Now that means I told you that if the outer shell, the last shell that we draw, it is 1 or 2 that is there, or 3, we call it what? Metal. Then you will now put plus on it. But how many electrons that is having? 1. Sodium 1 plus. So the same thing for this one. Now go and check. Calcium is calcium 2 plus. I told you how to. This is also metal. As a result of, calcium is what number? Number 20. That is atomic number. If you have to do the electronic configuration, it is what? 2, 8, 8, 2. 2 plus 8. That means this one will be 2. This one will be 8. Another one will be 8. The last one will be 2. 2 plus 8. That is 10, 18, 20. The outer shell will be carrying what? 2. Isn't it? As the outer shell. That is why you see 2 fall on metal. And note that the sign will always be plus. That is why they say Ca2 plus. Are we? Because what we need in solving this oxidation state is as a result of this charge that they have. +1, +2, and so many more. If it is aluminium, aluminium is 3 plus. Number 13, that is atomic number. Number 13, which is 2, 8, 3. Now what will be the outer shell? The last shell that we draw will take 3. And if it is 3, fall on what? Metal. 1, 2, 3. When you see it as the last shell, we classify them into what? We classify them into metal, and you put plus there. They are losing. They want to give out. They can't find 5 to complete them. This one can't find 6 to complete them, because everything must be 8 apart from this first one. Are we together? So that is why we classify them. But if you see some that you draw like this, so because that's what we actually need in solving. That is the valency we need. That their charges is what we need in solving this particular oxidation state. If you find one that maybe like carbon, they classify carbon into non-metal, and they also classify it into what? Metalloid. As a result of, carbon is what number? Atomic number is number 6. Hope I'm communicating. And know that when I do the EC electronic configuration, it is 2, what? 4. 2 plus 4 making 6. Are we together? Note, when I draw like this, that means the first shell will take 2, and this one will take 4. And I told you, if this is our last shell, 2, 4. This is the last shell that there is no any shell that we want to draw again. The last shell has taken how many? 1, 2, 3, 4. If you have seen it like that, what do we call them? Metalloid. That means this is half metal. Is having the properties of metal and non-metal. That is why they classify this. But you see, they classify this mainly to be metalloid or non-metal, because it's partially nearer to this. Are we together? So now, and it's also nearer to this, but it's as a result of they do classify this since it's the outer valence that is having, outer electron that is having, the last shell, it is 4. We classify them into what? Metalloid. That is that. In this topic now, you have also gained how we can classify element into metal, metalloid, then non-metal. Assuming I'm having what? I'm having chlorine. Chlorine is what? Number 17. Because we really need it. If you don't understand it, we can't get the question that we are about to be solving. Chlorine is what? Number 17. The EC now will be, that is atomic number, will be 2,8,7. 2,8,7. Now know that if this is the first shell, this is the second shell, this is the last shell, remain how many to balance? Remain 1, isn't it? If it's looking for just small one, like 2, like 1, you put minus there. Hope I'm communicating. When you put minus, what is the symbol? You put chlorine. But how many minus? That means it's looking for 1. How many minus is as a result of what make us to put minus? It is non-metal. Because I told you from 5, 6, 7, when you see it as the last shell here, assuming if it is 5 that is there as the last shell, or if it is 6 electron that is there at the last shell, or 7, you classify them into non-metal, and the symbol is minus. Then how many is it looking for? That is what you are going to put here. It's looking for 1. You know, in metal, what is there at the last shell, that is what we are going to put, Ca2 plus. But in non-metal, what is looking for, that is what you are going to put. Are we? So this is what we need in solving for the oxidation state that JAMB is about to be asking us on the likely question that they might ask. We need the charges, not the atomic number, not the mass what? Mass number. Hope I'm communicating. The last one, which is 8, is when we have like argon. Now the last one is that of noble gas. What are the elements we classify under noble gas? Firstly, know that I've defined what a metal is. These are elements which has its symbol of plus, not a symbol of plus alone. They are good conductor of electricity. Are we together? They are good reducing agents, and so many days. Why metalloid have the property of being metal or non-metal? Are we together? So they are semiconductor of electricity. That is metalloid, another name. Why non-metal? They have a charge of minus, and they are poor conductor of electricity, also poor conductor of heat, and many more. Why noble gas? These are the elements. As they don't have, they are not either looking for anything or releasing anything. That means they are not actually dashing out. You know, plus is dashing out. Now, since I can't find 7, let me dash out the 1. That is why it's carrying plus. In chlorine, I can actually get 1. That is why it's having minus. They do attract. Why in noble gas? They are not looking for either they don't want to dash, they don't want to lose. They are in between. That means they serve as the spectator. All the shells, the first one, the second one, the third one has already been completed. We call them noble gas. These are the what? These are the elements. Whereas they are not looking for anything. They completed their octet structure. Duplex structure is complete. Octet structure is also what? Complete. What do I mean? Let's speak argon. Argon is number 18. That is atomic number. The EC, which is electronic configuration, that is what I'm searching.